Good afternoon. Thank you very much. I'm very impressed everybody gave up the tea to join this lecture, which is impressive. So we have a tea lecture, which is very British, I would say, or very English. So I have this endeavor, this lecture on the engineering of the Panama Canal. Before getting inside this lecture, let me give you some of my thoughts on engineering, which is important to understand why we as human beings have been able to achieve so many constructions around the world, even arriving to the moon. Because with great engineering, everything is possible. This is one of the motto for the great engineers. However, we need a special engineering mindset. We have to think in the system. This is one of the reasons why it was possible to make the canal. It's a system. It was not a straightforward approach to make the canal. And there are these three properties. The first one, you have to see the structure where there is nothing apparent. So you don't know, but you have to see the structure, how it's going to happen. And this is really something extremely difficult. So you need a lot of imagination. People don't think that engineers have imagination. Engineers need a lot of imagination to achieve it. The second one is to adapt to the constraints. So at the beginning, you have some constraints, but during the ongoing of the project, you have different constraints coming over, and you have to solve them. You have to overcome them. Otherwise, you never make it. The third one, you have trade-off. You have to understand it. You have to be ready for the trade-offs. And we will see how not straightforward was the engineering of the Panama Canal. This is what is the situation in Panama. But we'll be back there very soon. As I told you yesterday, for the one of you that were present yesterday, the key person here was the French, Ferdinand Lesseps. Ferdinand Lesseps was this diplomatic person, was not engineering. He made the Suez Canal. So he tried in the 1880 to make also the Panama Canal as a sea-level canal. This is one of the pictures which was taken by the technical commission of the French people. And there is a reason why I'm talking about the French people, because with the effort of the French, the Americans could make it at the end of the day. And this is something we have to recognize when we do huge engineering making. This was in Limon Bay. That's where we'll be entering tomorrow, from Limon Bay in Panama. So at the end of the day, they failed after 8 years. They lost over 20,000 people at $250 million at that time. Actually, the company went bankrupt. But just to remind you again, at that time, President Theodore Roosevelt became President of the United States. And his philosophy of the presidencies was no wars, but I want to make the United States the most powerful country in the world. He was motivated and convinced that the Panama Canal would be the tool to achieve it. However, he was helped by another person who was William Howard Taft. He was a judge from a family of judges, and he appointed him as Secretary of War, and then he succeeded to President Roosevelt for 4 years. So he continued during the construction of the Panama Canal. But even him was not the president when the Panama Canal was opened. The last president was Woodrow Wilson. So these were the three presidents that were around during the construction of the Panama Canal. So engineering is also a matter of people. Who were the three people, the chief engineers that were nominated by President Roosevelt to lead the construction and the engineering of the Panama Canal? The first one was John Fidelio Wallace from 1904 to 05. The second one was John Frank Stevens for 2 years. And the last one, who lasted until the end, was a major was from the Army Corps of Engineers, Washington Goethals. Each one of them gave a contribution that will be looking detailed on what they achieved. But there were other human resources, of course, which were the working class people that were working on the engineering. Of course, I'm concentrating only on the American engineering. There were two payrolls they had. They made the gold dollars and the silver dollars. So there were the people on the gold rolls and the people on the silver rolls. Who were the people on the silver? There were the people working on the field, the people coming from the Caribbean, the people were underpaid. And these people were living in communities, I would say in a poorer level. They were sharing cafeterias where they were eating, and they were sleeping in common areas, in common dormitories. So there was a difference with the gold. The gold rolls, where the people pay with the gold dollars. These people were the people that were living in this modest but nice housing, and at a certain point they could bring the families and the children, because there was an effort to bring a sort of civilization in the forest where they were building the Panama Canal. So, the first one was appointed by President Roosevelt, was John Wallace. He was the former president of the American Society of Civil Engineers in 900. He managed to get the salary of $25,000, which was the highest salary for a government employee. Only president had higher salary than himself, so it was a big achievement. When he arrived, it was 1904, he found a terrible situation. He found the leftover from the French. This is what the French left in 1895, but it was still there when he arrived. He found rusting locomotives at the Empire, at the Culebra in 1905. And then he found all these dredging machines left everywhere in the canal. He was a very straight man, and he organized an international canal committees in New York. Because remember what I said yesterday, the company was incorporated in New York City. In this canal committee, he nominated the top engineers, not only from North America, but as well from other European countries where civil engineering was very important, notably from France, Italy, Germany, England, and so on. The problem that Mr. Wallace Army was a strictly organized engineer. So every week he was giving thousands of orders has to be accomplished by his technicians, engineers per week. So at a certain point, he was overwhelmed, and he resigned after a few months, leaving President Roosevelt in destroy because he didn't know what to do. So, what he did, he asked his war secretary, Howard Taft, and his wife to go and to convince Wallace to stay. So they took the ship and they traveled to Panama, where they stay with Wallace and his wife. Practically, they figured out that the problem was not only engineering, but there were a number of challenges to be overcome. The first challenge was the health. They had the control of malaria because people were dying, and they were helped by the discovery by Major Ronald Ross on that the malaria was transmitted by the mosquitoes. Because remember, the French, they failed because they lost 20,000 people because they did not know the mosquitoes were transmitting malaria. The second one was human resources. Who wanted to work in this hell, which was at that time the Panama Canal? Even the poor people, they were there, they were dying, they don't want to live there, they don't want to work there. And they lived as a second-class citizen. being paid with the silver roll, they were in this Jim Crow-like regime. Maybe some of you know what this used to be at the beginning of the last century. Was a sort of slave. They were having bad food and long hours and low pay. The third one was innovative technologies. And they were lucky because then in 1907, the construction fleet had a number of new machines, but luckily, in the next few years, new technologies made in the United States was being manufactured and be ready for the Panama Canal. So, the second one was John Frank Stevens. He was nominated by President Roosevelt in 1905, because then Wallace left anyway. This is in his office in March 1907. The first thing he did, it was a smart move. So you already know that we are not even talking about the project. There are only organizational and logistical issues to be solved. So the first thing he say, okay, I cannot have the people moving around in the mood like that. So he asked to his team to get reorganized with a railroad to move along the canal for moving the people and the freight and the tools. And that's what he did. He reorganized, you see, a railroad inside the excavation to permit the people to go up and down. And keep in mind, at that point, they have not yet decided if they want to do a sea-level canal or a low canal. They're just trying to see how they should excavate at that point. So they organized, this is a crew with the train, so they needed the crew, they need new people coming over. And this was successful. The second thing he understood is that one of the major obstacles was a very teeny mosquito. Because this teeny mosquito not only was delivering malaria, there were the female for the malaria, but the male, they were bringing the yellow fever. So he had to tackle this issue. It was lucky enough, because when President Roosevelt nominated Wallace, at the same time he nominated Colonel William Gorgas, which was a doctor, a surgeon. And you see how in the year, when he arrived in Panama, he became older very fast. But he understood that to win this challenge, he need healthy human resources. So he started to reorganize the hospitals. So he spent the 10 years. He was the only one staying all the 10 years during the construction. So he was lucky because they found the discovery how to cure the malaria and the yellow fever, and then the strategy to eliminate it. So he reorganized the hospitals. At the same time, he started to make excavation to canalize the water, and then covering the water with oil to avoid that the mosquitoes were flying around bringing malaria and yellow fever. And then, at the same time, they were spreading larvicide along all the roadside to minimize this spreading of malaria and yellow fever. And technically, we can say these are one of the statistics sooner after, in 1884, when the French were working, they had a death rate at 54% of death. So you see, I mean, that's when they went to work there, they were almost sure they would die. And then he was able, 1904, they worked very little because then Wallace left. Wallace was just doing paperwork. And then the rate went down. And this was a big contribution for the engineering of the Panama Canal, because with no people, you cannot make engineering. And this was the situation in Cologne before Dr. Goethals had to make all the changes. So he realized all these canals, and then he covered with oil today looks very simple, but there was the technicality they could do at that time. So, at the same time, there was the third issues. As I say, the French had the very old technologies. 10 years later, they had the new technologies. These were the new machines at that time they could use to progress. So, there was a new era, because after 2 years, Stevens gave it up, because he realized that he could not realize that. It was a big issue, very hard to achieve. He gave it up. And for what I see from the history, President Roosevelt was cranky. He could not understand why he resigned, because he was sure that Stevens was the right person to do it. So he decided to appoint Major George Washington Goethals, an army engineers from the Army Corps of Engineers, to be sure that, belonging to the Army, he would keep the project up to the end. And that's what at the end happened. You see that how he reorganized the work. This is the excavation total from the Central Division. How he arrived in 907, they went up, and then they stayed steady until they were getting to the close. Before, they were really advancing extremely slowly, so the target was always more into the future. And this is one of the meetings where they decided among 3 key projects. So they started to talk about the projects, and they decided that a good approach would be the lock system. Why they decide to go with the lock system? We have to see what is the situation in America. The major problem is and was the continental divide. You see the red line is the continental divide, which is mostly the mountains, which they go from South America to North America. And there was a passage just where they wanted to build the Panama Canal at that time. However, the continental divide is here. The mountain they stopped, but not the continental divide, was just passing by. And so this was a difficult point. If they wanted to make a sea level, which was the reason why the French failed, they had to excavate a lot to bring it down, all this continental divide to the level of the 2 oceans. So the decision was, okay, let's create a lake, and let's bring the ship up to the lake level, and then so we can cross, which seemed to the engineers a feasible solution. And you see, this was the project, which was approved at the end in 1906 of the Panama Canal. And you see, the difficult area was that one. So they went up, and then there were the Culebra. Maybe some of you there. This was the most difficult passage, where they would take a longer time to make the excavation at the Culebra. They called the Culebra Cut. You saw this morning when you did with the simulator with Lou. So this was what was approved, and that's what was on the map. You see, there was the cross-section of the canal, and this was where you see the Culebra. There was the continental divide. There were the difficulties, because if they want to build at the sea level, you see how much I have to take away. Today can be done. This could be done today. And even the French could have been done that if they would have found another route. They were looking for the shortest route. Instead, they could go for the longer route and make it easier. And this is the remaining of the continental divide. So this is a different understanding of the situation. And that's the way it's been built. This is the Panama City, which is the Pacific area. That's the Colón on the Atlantic. So you see, 3 docks, the lake, another small lake. It's done. this was all the excavation which was needed to achieve all that. This gives an idea how much should excavate. The French, they only excavated 7-8 million cubic yards. Then, for 3 years, until Goethals arrived, they excavated only 14 million. So we could say it was very slow advancing of the project. And then, with Goethals, they excavated 232 million cubic yards. So the total made 324 million cubic yards to realize that. So you see the height of the water surface of the canal became 85, which is the actual one. Actually, with the ship, you do less, but the maximum would be 85. So, but how do canal lock they work? Because we make it a canal lock. So, this was invented in the 1490, the canal lock. Leonardo da Vinci, I don't understand why, nobody knows why, he had so strange ideas, this guy, including, the invention of the helicopter, but he did not have the engine. So he understood that by putting two locks at 45 degrees, it would simplify the movement, because now we understand physics, so we know that if you do that way, the pressure of the water is stable, the dynamic of the water, so it's very easy to control. So with a small power, you can move big and you can stop the water. And this was the original design of Leonardo da Vinci. Actually, he made one. In 1497, he made one in Milan, which is still there. Now, of course, it's with the motors, with the electrical motors. So he realized that. So the engineers at that time have to use his technology to make the locks. And if you see from the physics, it's very simple. You share the pressure. You have to create these two angles to avoid that the water is flowing from one side to the other side. And with this, very simple, you can make a lock. But the lock is huge. This is one of the lock under construction in 1912. So imagine if they could not use this genius invention of Leonardo da Vinci, they would make another sort of door that we should use a lot of energy to achieve it. And this gives you the idea of the size of the lock compared with one of the silver roll workers which was working over there at that time. And this is the engineering of one of the lock. It was really a huge effort. So, at the end of the day, they had to create this communication. The lake did not exist. The only thing which was existing was the river, the Shangri River, which is the one which goes from the lock at the Lake Gatun up here. But they created the dam over there. I will show you very soon. And then they created another small one here. The difficult part was to cut here, where there was the continental divide. So you see, it's not a straightforward project. It's not something that you put on I want to build this ship. Okay, we make the concept, we make the design, then we talk with the client, we make a modification, we go to the shipyard, we build, we deliver. No, it was not like that. Not at all. They were changing every day, the chief engineers with the engineer to sit down, okay, now we have this, how we do that, change it, make it. That's what they did. At the end, the system works like this. You go up and you go down. This has a part of the excavation, and you have to remark how poor were the condition of the people working there. And the risk. You can imagine here, you can have a sliding of the mood on them. That's what usually it could happen during the work. And look where there were the houses of the gold rolls people, over there. living over there. And this, what I was telling you, was a landslide during the cut. So everything was destroyed. We don't have any statistics how many people died during this accident. Over there, I was only almost a little bit more than 1 year before the opening of the canal at that time. Now, how they made it the lake? Okay, let me see if I can show to you. You see, this were the lock. You see the small canal, the French, was written French. This was the part which was excavated by the French. But they went in a different direction, and they made at this part the lock, and they made the dam here to create the lake. So this was the project which was modified during the construction of the canal. So the French made a small canal at that time. This was the visit of President Roosevelt, who enjoyed to take pictures on the machine, like he was a worker. And how they had to work there, they had to use dynamite to do that, because there were big things to be done. This is a small movie.
A little job connecting the Atlantic and Pacific. A little job.
And the other people were observing from the dam. So let's go back to the picture where before. So they were on the cut, they are working. And finally, they were able to make the cut. That's where is the old canal, which is still there. And the first water was flowing inside this area, which is the Coimbra Cut, which is the area which goes from Lake Gatun going to the locks from the Pacific side. This is just a few months before the opening of the canal. And you see how the water is filling up in the canal. And it's clear and understanding how much water is needed for operating the Panama Canal. A lot of water. That's one of the reasons they also realized the lakes for this particular reason. Now, these are some of the diagrams of the Miraflores locks, which are on the Pacific side. We are not going to transit in this one. So these were detailed design, and there are things which are clearly what happened. This is the cut of the Gatun Dam. This was the design of the Lagoon Cut. And this is the making of the dam. Of course, when they made the dam, they realized also the power generation station at the same time, which is still in operation. It's generating all the power they need. Of course, you know that until 1999, the Panama Canal was US territory, and then it became independent with the new treaty. So, with all this complicated, not straightforward strategy for the engineering of the Panama Canal, on August 15, 1914, the first cargo crossed the canal. However, the same month, the first World War started. So there was a small ceremony with the local people, but there was not the official opening of the canal, which means President Wilson did not travel to Panama Canal because he was busy with the war. And the ceremony was postponed until 1920. So this is the first ship, which is the Ancon, was a US steamer, which was entering the canal, crossing the canal. it caused, and there was the loss, which was counted at the time, of 5,609 people. This is how the canal locks works. And that's what we are going to do tomorrow. We'll be doing these first 3, stay in the canal, going around and go back. This is the way to go into the canal. Now, let me give you a small summary. What happened? In 1882, the project started. The French started the construction of the canal. The French finished 2/5 of the canal, which is not bad. But the canal company, the French canal company, went bankrupt. Then, American John Valais was appointed as chief engineer of the canal project. He had many problems. One was another mudslide at the Coulombre Cat, because the Coulombre Cat was the problem for all the engineers that were involved there, to cut the continental divide. So John Stevens is made by chief engineers. And at the end of the day, it was a good choice for President Roosevelt. So he changed his mind, and he decided to make a log canal, not a sea-level canal. So minimizing the engineering work at the Coulombre Cat. So he also increased the morale of the workforce, namely also because he was improving the health condition of the people, as we have seen with Gorga, with Dr. Gorga. However, he quits at a certain point because he felt that the task was too big to achieve. So President Roosevelt nominated an army officer that finished the Gat Lagoon. He finished the Coulombre Cat, and he was able to open the canal. At that point, as you know, by 1909, President Roosevelt was not the president anymore of the United States, so he was not on president when the canal was open. But the story did not finish there, because what happened? In June 2016, they made some work, because until that time, there was a limitation on the size of the ship that could cross the canal. Of course, the freight transport around the world multiplied a lot. The only ship that could cross the Panama Canal were ships of about 5,000 standard containers. Today, we have ships with 20, 25, 30,000 containers. They still cannot cross the Panama Canal. So the Panama Canal decided to enlarge the locks by making additional larger locks, which some people claim is one of the problem with the shortage of water in the canal. And this is what happened. They had to enlarge the famous Culebra slide, so they had to enlarge it to permit the passage, the crossing of larger ships. And you see here what happened. This was by the time they did the first Culebra Cat. This is the one they did, they finished in 2020. Quite, well, on the graphic looks small, but was quite a huge achievement by excavating the Coulombre Cat to permit the passage of larger ships. To give you an idea how big are these ships, there were the famous Panamax. The Panamax were long at least 1,000 feet, maximum 1,000 feet, and they had a beam of 110 feet. Now, with the new locks that you will see tomorrow, they should be on our left, I believe, you can have a ship of 1,400 feet long and a beam of 160 feet, which makes a huge difference in the size of the ship. And to give you an idea, that before they could get ship with 5,000 containers, and now they get ship with 12,000 containers. So it's been, in terms of increasing of the transit of containers, It's quite important. And this is, we'll be crossing an existing locks, and this is the new locks. And this is, this is a similar design, but I give you the situation with the water basin. So there you need a lot of water, which is reconverted every time that you have the tank empty and filling, the water is reconverted in the water basin. So they need excellent water management to keep the canal running all the time. And this is the project. Now this has been made. And you see the existing canal and the new locks with the tanks. So it's been a big change. Now, when engineering touches everything which is in the nature, we never know exactly what's going to happen. We can make a hypothesis. We can decide a sort of a strategy, but we are never sure how the nature is going to react. So, but before going on that, you can play. If you have time, this is a game which was invented in the 900. Maybe we should ask Viking to put a few of them on board. It's very easy to play. If you are the winner, you have to be the first to land on the 4 rocks and avoid the third rocks to exit the canal. So, you know, it's like a monopoly, but you don't make money anyway. But I think they sell online. Very easy to buy. Now, so at the end of the day, this is the situation where you see with the 2 locks, the new and the old. The Gaillard cat is also known for the Coulombre cat. They have 2 names. One thing which is important, usually you think that you are going from east to west from east. It's not true. The canal is from north to south, geographically, or from south to north. I mean, the operators know that because they have the route going south. But we, as normal human beings, we believe that you cross like this. We don't. We cross like this. It's like a small diagonal going down there. Now, what would have happened if the French would have realized the canal? As I told you, the French, of course, had, before the Americans, a superior technology because they achieved the Suez Canal. But for some reason, since Mr. Lesseps, remember the French leader, was not an engineer, but he wanted to decide everything. And he liked the people in power. He wanted to go for the shortest route to cross. If he would have taken a longer route, maybe it would be much easier to make a sea level canal. And if you see from an engineering standpoint, a sea level canal would be much easier to handle and to manage, because naturally you would get the water coming from the 2 seas. To enlarge it would be much easier. You just need to enlarge, and the water comes in. The system with the locks, with the dam, with the lakes, it's what is called an over-complicated situation for an engineering project. But they failed because they didn't want to be engineering, but they want to be political. And that's where they make the mistake. Now, what is the epilogue of this? America had succeeded where France had failed. And as I told you yesterday, they made the United States of America with this philosophy of Theodore Roosevelt. At that time, America became the most powerful country in the world because they could control the trade between the 2 other continents. But without the failure of the French, America might have also failed because they learn from the mistake, which is typically, in engineering. For example, in engineering, we take from the aviation. You say you fly, you crash, you fly. You mean you do something, you make a mistake, and you understand from the mistake, you fix it, and you fly again. And this is exactly what we do in engineering. When we do project, we cannot do straightforward. The success of Goethals has been influenced by the failure of Stevens. You remember? He was the third one. But Stevens' success had been influenced by the failures of Wallis. And Valley's success has been influenced by the failures of the French. So everything is always interconnected. So we can say that with this ingenious engineering triumph, that the Panama Canal is an unparalleled conquer of the nature. Indeed, the Society of Civil Engineers, they have 8 wonders of the modern world. They call the Panama Canal the 8th. The other one are the Channel Tunnel between England and France, the CN Tower in Toronto, the Empire State Building, the Golden Gate Bridge, and the Itapu Dam between Brazil and Portugal, and the 8th being the Panama Canal. As you heard, last year, some of you already asked me this question, there was a problem of drought. And this is done for the climate changes, but can be done also because they have these new locks, which they demand much more water. So this was the situation on January 2023, and this is the situation in July 2023. Right now, everything is okay, is fine, so we should be navigating safely tomorrow morning in the Lake of Gatun. To give you an idea what is going to happen tomorrow morning, we'll be entering, well, this is for the old crossing, we're not going to old crossing, we'll be stopping on the number 3. So we'll be entering there from the Atlantic Bridge. We have to board the pilot. After we board the pilot, we'll be engaging the first lock. Once we enter the lock, the motors are shut down, and the ship is maneuvered by the mules. You will see tomorrow on the side there will be this electric locomotive that will be maneuvering the ship. It will be very tight. So the Gatun locks are 3 locks, so we'll be doing 3 times up. Then we get in the lagoon lakes. Then I don't know if we'll be anchoring or we'll be navigating around until Capitan we get the authorization to go back. Then we do again 3 times back, and then we'll be docking in Cologne tomorrow. This is all for now. If you have any questions, I'm available, or if you have any other thing you would like to learn, I will be available to reply to your questions now or later, anytime you want. Please.